Okay, let's talk about these here real quick. Number 2. Number 2, x plus 4 times x plus 2 times x minus 1 times x minus 3. Just a quick little side note here. If I were to multiply all of these factors together, so distribute them all together, I would end up with x raised to what power? The fourth, right? Because when I distribute these two together, I get an x squared, right? Then when I multiply that by the third one, I'd get an x to the third. Then when I take that times the fourth one, I'd end up with x to the fourth. So if you were to multiply all these together, you'd end up with an x to the fourth polynomial, a fourth degree polynomial, okay? Which you guys know then the end behavior would look like this, okay? But that's not what we're after here, but I just wanted to connect it to what we have been doing, okay? So you have a fourth degree polynomial that's been factored to this. So what x values make this equal 0? Or in other words, where does that fourth degree polynomial cross the x-axis? What are our answers? X equals -4, -2, +1, +3, right? Those would be where the graph of that fourth degree polynomial crosses the x-axis. Those would be the zeros of the function. Those would be the roots of that polynomial equation. All these things mean essentially the same thing. Okay, they are actually also the x values that satisfy this equation. Any questions on any of that stuff that I'm saying so far?
Is it also called solutions?
They can also be called solutions for this reason, because if you plug in -4 for x, it would satisfy this equation when it's set equal to 0. So it's a solution to the equation. Yep, good. All right, nice. Okay, next one. It would also be a fourth degree polynomial, this next one. Because you would have x plus 4, x plus 4, x plus 2, x plus 2. So there'd be 4 factors. But because x plus 4 repeats itself twice, it's just faster to write it x plus 4 quantity squared. Okay? Does it have really any impact on the solutions to this thing?
No.
No, what are they?
-4, -2.
Yep, -4 and -2. Now, to go a little bit deeper into that here, and we'll get into this later in this unit, officially, we will say that x equals -4 is a solution or a 0 with a multiplicity of 2. And what that means is, if you were to write out all the factors individually, x plus 4, x plus 4, x plus 2, x plus 2, and then found the zeros or the solutions, wouldn't you write -4 twice? And wouldn't you write -2 twice? So what we typically say then is -4 is a solution twice, or -4 is one of the zeros with a multiplicity of 2. -2 is a root with a multiplicity of 2. Just means it's a root twice. Okay? Graphically, what it would mean, what happens, is anytime a root or 0 is a 0 more than one time, it means the graph comes down and touches the x-axis at that value and then goes right back up. It doesn't actually like cross it. It just touches it, goes back up. Or if it's coming from the bottom, it touches the x-axis and goes back down. And you'll see that here a little bit more today. But anyway, I'm just trying to add more to what we did here. Everybody good on 3? Number 4 looks a lot like number 2, but they threw a -2 at the very front. Did that have any impact on your, or I guess the values are a little different. Did this have any impact on what these solutions were? No. X equals 4, x equals 2, x equals -1, x equals -3. So it didn't have any impact on where the x-intercepts were, but it would have thrown a -2 on that leading coefficient if you were to multiply them all together. So then you'd end up with a -2x to the fourth, so the end behavior would be like this, because you'd have a negative number in front of the x to the fourth. But it still crosses the x-axis at those 4 different spots. Okay? I'm throwing a lot at you, connecting it to what we've done, so. Number 5, were you guys all able to do those mentally?
Yeah.
Yeah? Some of us maybe know. If you can't do them mentally, what should you do with 2x plus 8?
Put it into
Put it into an equation by setting it equal to 0 and then solving for x. So you'd end up subtracting 8 and then dividing by 2, and what do you get? What? Negative 4. How about this one? 3/7. How about this one? Positive 10. So x equals negative 4, x equals 3/7, and x equals positive 10. That's it. Why was number 6 a little tougher? Yeah, it wasn't factored for you, right? It was in standard form. You needed to factor it. X minus 4, x plus 1, right? No. X plus 4, x minus 1. That look better?
Yeah.
So the solutions would be x equals negative 4 and x equals positive 1. Is that right?
Yep.
Okay. Number 7. X equals 0. X equals 3. X equals 1. X equals negative 0.75.
Got that one.
And number 8, that could be factored more. X plus 2, x minus 2. So what would be the solutions to number 8? Negative 2, positive 2, negative 9. Is that all right?
What's that last one?
Say it.
What's the other one?
I factored x squared minus 4. That's the difference of two perfect squares. Remember how we factored the difference of perfect squares to x plus 2, x minus 2?
No.
So we had the difference of two squares rule last week. A plus b, a minus b. So like if you saw x squared minus 81, x plus 9, x minus 9. Okay? So make sure if you see the difference of two squares anywhere, you factor it the rest of the way. Okay? Because this one ended up with 3 solutions, 3 zeros. Okay? 3 x-intercepts. Which would match the degree, because x squared times x is x to the 3rd power. All these connections, hopefully I'm helping you make here a little bit. All right? Okay. You will need to go to student.desmos.com. Student.desmos.com.
Close to getting that. Oh, my computer's dead. Look at it.
Throw another one at you.
Just say it. I don't recall it.
I'm just helping you.
You had it by a finger. You had a finger.
What to do is that. And it's slipped out and it's holding it on with your right.
Student.desmos.com. And we will work a little bit more with this connection between the factors and the zeros, or the factors and the x-intercepts. You'll work a little bit more with this.
There it goes. Some people did not see the code.
TA9YJC. TA9YJC. Go ahead and get started.
People that was like TJ Maxx.